Georgia State University and the Project RISE initiative are proud to introduce the GSU Innovation Imaging Hub. Led by Dr. Phoebe and Brene of the Department of Physics and Astronomy, and a team of principal investigators representing a variety of disciplines within GSU.
Georgia State University is the home of the Innovation Imaging Hub initiative, where scientists and scholars from various disciplines carve out time from their research to focus on a long-haul endeavor.
The Georgia State University Imaging Hub is quite special in that it's making the effort to try to bridge what I think are somewhat artificial differences across the disciplines in order to think about common approaches to problems we all face when we start to take a look at these kinds of imaging-related research issues.
To understand a problem, nature often requires a change of the angle from which it is approached.
I think Georgia State is special in that we really are making an effort and succeeding in starting to have conversations across the disciplines, starting to think about shared facilities, and starting to think about new initiatives in this broad area that are going to be exciting and are going to be new.
Under the simple premise of teamwork, these experts on subjects ranging from astronomy to biology to computer science and mathematics have found the perfect ecosystem to step out of their conceptual bubble and delve into other fields that allow them to continue advancing their research.
I can't do this work by myself. I need the mathematicians and the computer scientists to work with. And I need the biology people. I can't do any of that either. This is inherently a very large collaborative kind of process that cannot be done by me. And it's great. If this hub didn't exist, we wouldn't even be looking into any of this.
The scientists at the Imaging Hub are collaborating to adapt seemingly disjointed concepts towards finding solutions to problems and cures to diseases. One of their aims is to revolutionize how doctors treat and diagnose eye conditions. By leveraging the methodologies used in astronomical research, this team of experts is modifying its approaches and findings to suit the scale of the human eyeball. It's a unique group effort for a higher purpose.
I'm doing science, to improve the life of other people around me, to make life worth living, right? Like art, science is not only purely utilitarian. Otherwise, I wouldn't be doing astronomy.
Poet Herman Melville describes eyes as the mirror of the soul, as they reflect humans' thoughts, feelings, fears, and desires. From a scientific perspective, the human eyes decode the information to provide a clear picture of what we are facing in the physical world around us. Scientists see the world in the same way.
Nevertheless, they're all images that are made on detectors that have pixels, and therefore we're all dealing, in some sense, with similar kinds of questions of how close can you resolve images across the pixels that you're using for your imaging algorithm. How sensitive are these to the contrast and brightness? How does it change with color? The scales that we're thinking about are vastly different in terms of looking at stars at unimaginable distances away and comparing that to things that are unimaginably small in our laboratory.
Astronomy was born from the observation and interpretation of stars. This simple practice of looking towards the sky enabled communities to predict seasons, which later became a key application in agriculture. In other instances, scientists observe the skies with their telescopes and apply their findings to reinterpret results in other disciplines to predict significant events such as diseases. This kind of interdisciplinary collaboration is necessary, and thanks to the GSU Imaging Hub, is now possible.
It's like the weather, you can't change it, but you can give people warnings for hurricanes and the like, or earthquakes is the same. So a good warning can help you mitigate the damage a lot and take protective measures.
Such predictions, and more like them, will be possible in the future thanks to GSU's Innovation Imaging Hub. In this space, interdisciplinary researchers come together to envision scenarios where individuals visiting an ophthalmologist can prevent any type of eye disease through the interpretation of their exams, much like astronomers do with star observation.
We're quite excited now to talk to colleagues across different departments and say, well, this is the kind of image data that we get when we look at outer space. How does it look compared to what you're looking at through the microscope?
Guys says the Innovation Imaging Hub initiative is synonymous to putting on the glasses of science and bringing to focus the blurry spectrum in front of them.
We're exploring the world in so many ways, and we do so through images. We try to extract images of very tiny things, biochemistry, physics of very, very small size objects, out to the things that we're working on, of stars of immense size at immense distance.
A lingering question remains unanswered. How can these scientists connect the pixels, and how can the public reap the benefits of this unique collaboration?
Identifying parts of the image that are important that might be hidden in the background. So picking out small details amongst the background is one part. Comparing something that's really, really bright to something that's really, really faint right beside it, that's another big part of it, the contrast problem. And we have similar kinds of issues to deal with when we are looking at the stars.
These scientists have their eyes set on the future. One of the many goals of their research is to help people keep their vision well into old age.
If you can apply these algorithms to imaging the retina, then you can detect something called macular degeneration, which is the leading cause of blindness in 65 plus citizens in the US. So I think it affects something like 10 million people. So that's really something that we want to make progress on.
Though skeptics may claim that scientific discoveries linger in labs and lose their effectiveness by the time they see the light, the GSU Imaging Hub proves that interdisciplinary collaborative forums can save time by providing scientists valuable tools that can benefit their work and societal progress.
We want to bring an institute where we bring together academia, the private sector, and the government into a center of excellence, basically, where we have experts coming through all the time in these areas and coming together to solve problems in that arena. And there is significant interest in the DoD for doing something like this. We're right at the very beginning, but we're hoping that we can make this materialize. And if we do, then GSU would be at the hub of something that would be of national importance. So
Yes.
this is going, and the reason I bring this up is because we need, one of the cornerstones for space domain awareness is imaging. But with a hub where we have expertise from many domains looking at similar problems with different visions, we hope that we can leverage that and make our imaging component very, very strong here.
Ultimately, what the Innovation Imaging Hub seeks to accomplish is to provide these scientists with both the resources and the community that they need to make progress and find solutions to real-world problems.
I believe by trying to solve real-life problems, you make progress in actually the science that's behind it. Because you will need new methods and you will need new theory to help solve your problems.
The interdisciplinary collaboration is, without a doubt, the most crucial element of the hub. At the Georgia State Innovation Imaging Hub, scientists are examining real-world problems and devising global solutions in a diverse scientific setting to advance the human condition. By housing this interdisciplinary collaborative research under one roof, Georgia State University is undertaking an overarching endeavor that could possibly be revolutionary. From the GSU Innovation Imaging Hub in Atlanta, this is Brene reporting.